So there are several executive processes that we're going to talk about, and in this particular video, we'll first start talking about executive attention. Now, what is executive attention? It's the kind of selective attention that typically acts on the contents of working memory and then directs subsequent processing so as to achieve some goal. So this sounds like a whole mouthful, but it's basically what keeps us on track as we work through particular tasks. I think it will become more clear what it is when I explain to you how we, for example, can measure it. And a common measure for this, which actually gets used in clinical settings a lot too, is the Wisconsin card sorting test. What happens in this test is the following. You see people get a deck of cards, and there are four cards on the table, and these cards differ in several different ways. So they differ along the dimension of shape, they differ in the dimension of color, and in numerosity. So some cards have 2 items on them, some 1, some 3, some are red, some are green, some are triangles, some are circles, and so forth. So what happens in this task is that a patient or a participant is giving a deck of cards in their hands. They have the 4 cards on the table, and then they're being told, please sort the 60 cards under the 4 samples on the table. I won't tell you the rule by which to sort, but I will announce every mistake, and then the rule will change after you have 10 correct placements. So in other words, the person starts playing, and maybe the first card that they grab from the deck is this card right here with yellow shapes, 3 yellow triangles on it, and they have to figure out by which rule to sort. Now originally that's impossible to know because, is it yellow? They would put it here. If it's triangle, they would happen to have put it here too. If it's by amount of items on the card, then you would put it over here. What happens then is that the person starts playing, and then this is pretty symbolic of how this goes. A doctor in a white coat then tells the person whether they're right or whether they're wrong, as you see in this case. So you can see here, person puts down a card based on the number of items, and apparently that's not the rule. So maybe after that, this person may try to put it on green, because maybe it's based on color, and if that happens to be the rule at that time, the person here would say yes, it's correct, and then you would keep playing. After you get 10 of them correct in a row, then the rule switches and people have to start all over and figure out the next rule. So why is this useful clinically speaking? Well, this simple task actually accomplishes a couple of things, and it requires a couple of things to work well. So first of all, you got to be able to switch attention from one rule to another. Once you've figured out the rule, you can stick with that for 10 placements, but after that you got to be able to let go of that rule and then switch to whatever the next rule may be. Now it turns out that people with damage to the prefrontal cortex have a very hard time doing this. They may actually be able to figure out what the original rule is, but once they're stuck with that rule, they can't really redirect their executive attention in the way that healthy individuals do. Healthy individuals can then let go of that rule and start working on replacing the rule. And what's interesting is that eventually they can do it, but it would take them much, much longer to figure out that the game has changed, that the rule they're operating on is actually incorrect. And interestingly enough, some of these patients can actually tell you that the rule has changed, but nonetheless, they can't really let go of the rule that they'd figured out, and they keep playing the wrong cards. So that is a really useful clinical test for the functioning of the frontal lobe. Now, there are other tests as well. So, for example, the Tower of Hanoi is a common test that gets used in clinical settings. And the goal in this task is to move a bunch of discs from one pack to some target pack. So let's say you see 3 discs here, a blue one, a green one, and a red one. And let's say that they all need to be moved to the pack on the right. But there's one very simple rule. You can only move 1 disc at a time, and you're not allowed to put a larger pack on top of a smaller pack. So what this means is that, for example, I could move the blue pack over here to the blue disc over here to the pack in the middle. So like this, for example. And now in the next step, I wouldn't be allowed to put the green on top of the blue one because the green is bigger than the blue one. So I'd have to put it over here. Now after this, I would then be able to move the blue one onto the red one. And actually I'm seeing now that I'm doing this one incorrectly. So let's do this again for a second. Oh, computer error. So let me show you the correct solution. You would move the blue one to the right, the green one to the middle. Then the blue one can go on top of the green one. Now the red one can go to the right, blue one can go to the left, green one can go on top of the right, and then the blue one can go on top of the right. So you see that this takes several steps and you need to break it down. And then what you need to do is actually select sub-goals rather than the overarching goal right from the get-go. So there's a couple of things here that need to be happening. First of all, you need to focus attention on the relevant disk and then ignore the other ones for the time being. But then also switching attention back and forth between the disks and decomposing the overall goal of getting that whole stack to the right into smaller sub-goals so that you can actually sequence those correctly and get one at a time done. Now, this is a notoriously difficult task for patients with frontal lobe damage. And again, it's used in clinical settings because it's a useful way of measuring how well the frontal lobe works. Now, another task, and I mean there are many, but another task that we've already come across in this course is the Stroop task. And that too is very useful for measuring executive functioning. So again, the task here is to either have to read the word, which is the easy condition, or to say the color of the ink. And again, green printed in red would be an incompatible trial because you're inclined to say green, but the answer is actually red, answer is actually green, answer is actually blue, and so forth. And the compatible cases are much easier because there you just read yellow, the color is yellow, so everything screams yellow. Now, there again, people with frontal lobe damage have a hard time, and we'll see in the next video that part of the reason for that is because the frontal lobe is really specifically engaged in setting up the task here in the right way, and setting it up right allows healthy individuals to actually inhibit their tendency to immediately read the word. And that inhibition is necessary because then that allows them to actually say the color of the ink instead. So I'm going to go through that in the next video.